Hello friends, this is the second video of our parallel processing concept. So in the first video we understood the fundamentals of parallel processing and there we understood some important concept like what is server group and where we can check the server group, right? And how we can use the transaction SM66 to see all the work processes, to check the all the application server which is available there. So this is the transaction SM51 where we can check. So these all information in detail I have shared in the first video. Okay, so uh, before watching this video, it is recommended to go to the first video and see in detail, because fundamental is very important in order to understand the parallel processing concept. Okay, in today's video we will see the practical aspect of the parallel processing. Like we will take one example where we will see without parallel processing it is taking how much time, and with parallel processing when we are going to assign multiple tasks to multiple work processes, okay, then how much time it's going to take. Okay, so maybe we can go to the system and we will check over there. So I have already prepared some data over here. You can see this is my material number, this is the material type, this is industry sector, this is material group, and here this is the unit and material description. So with the help of all this data, what I am going to do, with the help of a BAPI, I'm going to create the material. Okay, so first we will see like how much time it's taking without parallel processing. So I have taken over here first 1000 material, over here, uh, in a normal way how much time it's going to take. So for that I have created one program. Okay, so this is the program Z para test. So in this program, let me explain a little bit about this program. This is the first statement uh, uh, with the help of which I am going to get the F for help, and I will get the file location from where I will get the data. This is the function module through which I will put the file data into our internal table. And here just I want to remove all the material which I have created, because today multiple type I have created the material, so I needed to delete those material. Okay, in order to just maintain the consistency in our table, so that I can reuse multiple time the same material. That's why for today's material I'm finding it here, and with this delete statement I'm just deleting them. Okay, and here I have applied one timer with the help of this timer class to just I'm getting the instance over here, and with the help of this object instance I'm getting the initial time. Okay, and here I'm putting the loop on this it underscore mara, which I'm getting from my file. So all the material information I'm getting from the file in this internal table, and this internal table I'm putting in the loop, and one by one I'm creating the material. So for creation of material here I'm preparing the work area and required variable, required internal table, everything which is required to pass into this BAPI material save data, and just I'm passing those parameter in order to create the material. Okay, so and once there is no problem, there is no error, just I'm committing one by one all the material. Okay, and just I'm displaying the message. So that's it. This is the simple example, but it's very effective, we will see. Okay, so here 1000 material I'm going to create, and we will see how much time it's going to take over here. So let me run this program. Okay, and press F4 over here, and this is the 1000 material already I have copied and paste over here in first 1000 text. You can go over here and you can see. Okay, so here if you see I have put 1000 materials, right? First 1000 materials I have put ppt 1000, right? So just once again I'm saving it, I'm going to run, and let us check how much time it's going to take. Okay, just I have run it, and it will take some time. Okay, so this is in a normal way, like normally when we create any program, normally we are going to use like this. But This is 1000 materials. Okay, but suppose we are having some millions of material and our customer is willing to, improve the performance. They are asking repeatedly to improve the performance, and if we are having the sufficient system resource, we can go ahead and we can use the parallel processing concept with the help of a dedicated server group. Okay, so maybe I can stop the recording over here, and I will show once it will give the output. Okay, how much time it's going to take. This program is still running, it's taking some time, so maybe it will take somewhere around maybe 2 minutes, or maybe maximum 3 minutes. If it's going to take more than 3 minutes, it will go into dump, and because a dialog work process is here having the set limit as 300 seconds as a maximum limits. So if it's going to take more than 3 seconds, it will go into dump. Before that, if it's going to complete, that means maximum, within 5 minutes it has to complete, otherwise it will go into dump. So in beginning I started with 40,000 materials, and it went into dump. Then I have tried with 20,000, again it went into dump, and then you can see now it has come over here, the output come, and total time you can see it has taken, the total time is 126 seconds. The total time for 1000 materials, it has taken 126 seconds. Okay, so maybe I can take little more material. Okay, so that when we are going to use the parallel processing, we will be able to see some significance result. Okay, so somewhere I'm going to consider the material. So here it's 126 seconds. So maybe if I'm going to take the 2000 materials, okay, so it will be taking somewhere 252, maybe. So maybe I'm going to take 2000 materials. I'm going to uh, change the name of the material, and I will use, so parallel processing test TT. Just I'm going to keep it over here. I can keep the same, but just I want to change the name. Okay, 1000, and maybe uh, 500 more I'm just going to take. Okay, so double clicking over here, and 1500, I can take the 1500 materials, or 2000. Let me take the 2000. We will see how much time it's going to take. 2000 materials, just selecting 2000 materials now. Copy this one, I will paste over here. Oh, I've done mistake. No problem, I will copy once again over here, and let me check. 2000, it's fine. Copy this one, I will paste it over here, save. So 2000 material I have just copied. File name is the same. Okay, just I will give one space, so it will be easy for me when I'm going to select the next time. Okay, just I will save, and once again I'm just going to execute this program. Okay, so the file name is the same. In the same file name we are having 2000 materials now. Just I'm going to execute this one, and this time maybe we'll have to wait some more time, and it will take somewhere around, uh, 4 minutes and half seconds. So by that time, just I'm going to pause the video. Okay, and we'll meet after some time. And wow, it got successfully executed. You can see here that it got created. We are able to see, and let us see how much total time it has taken. So total time you can see 243 seconds it has been taken, 243 seconds. So this time, total time is there in the microseconds, so 243 seconds total time it has been taken by the system to create the 2000 materials by that particular BAPI. Okay, now what I want to do, with the help of parallel processing, I want to see the improvement, how much time it's going to take. So let's go ahead and start writing the code for the parallel processing. Alright. The same program, maybe I can copy the same program. I don't want to disturb this program. So let me implement parallel, something like that. I'm going to create the program. Just I want to copy the existing one. Get parallel test. Click on this copy button. Copy, and I'm going to select all the module and everything. Click on this copy button, and I will change the name a bit over here. One, it is not required, but we can do so. Click on this OK, and local object, assign a package. We have assigned, saved. I'm going to change mode. Just I want to see whether it's working fine or not. Yeah, it's fine. It got properly copied. So now what I'm trying to do over here, that okay, so now what I'm trying to do over here, that I want to implement the parallel processing over here. So what I will do, that in it underscore mara we are having, if we see over here in it underscore mara, we are going to have the 2000 materials, right? Because 2000 materials we have copied, correct? So here in it underscore mara we are going to have 2000 materials. So we will check how many total work processes we are having available, and accordingly we will take the decision. So total we are having somewhere around 15 work processes, but out of these 15 work processes we are having uh, 9 0 to 9, that means total 10 work processes we are having for the dialog work processes. Okay, if you don't want to check from here, you can go /n sm51, and from here also, as discussed yesterday, you can check, right? Double click over here and you will see the total available dialog work processes is 10, right? Out of one which I am using currently, 9 dialog work processes is still available, but you cannot use all the 10. Some SAP standard documentation tells that you have to leave minimum 2 work processes, and somewhere I have seen in the SAP standard documentation 3 they are telling. So in the earlier version, like in 6.0 version documentation, maybe I can share you over here, I can show you. So here I have copied and pasted, right? Here you can see this is a SAP standard documentation. From there, 3 dialog work processes minimum should require. Okay, and in the newest one, maybe I can show you. I have opened that one, and here I can show you in this documentation, it is telling the minimum we will be having the 2 work processes available. Means minimum, we don't have to use all the work processes. We have to leave minimum 2 work processes. So somewhere I have just seen, let me check. Okay, so here also it's at least 3 dialog work process we should available. So maybe I was mistaking. So we must have at least 3 dialog work processes left. We are not supposed to use all the dialog work processes, right? So here we are having total 10 dialog work processes, right? And out of 3 must be left. Okay, we can consume only, you know free must be 3, 7 we can consume. Okay, so totally it is having 10, one I am already consuming. So still, you know still we can use the, after leaving the 3 we are having 7. Then out of 7, uh, uh, out of 7, one I can use for my use, and the 6 I can use. So maybe I'm going to use the 5 work processes. So for I can divide these records into 5 chunks. Okay, so total we are having 2000 records. So in chunk of 400 I'm going to divide the records, and for each work process I will assign the 400 records to update the material. Okay, so how to do that one, that is the important thing. So what I will do here, you can see all these things we are doing, right? All these things we are doing over here. So for doing all these things, to put all these things in a parallel processing form, we have to require to create, a RFC function module where we can put all this logic. Okay, where we can put all this logic. And so let me go and create the RFC function module. Go to AC37 and Z parallel wrapper FM to update the material I want to create. So just click on this create. I'm just going to select some already existing function group, and here uh, wrapper FM for parallel processing. Click on the save button. Okay, click on this. Okay, and we came over here. So from outside I'm going to get the, you know the table of 1,000 materials, right? So I am underscore Amara, maybe I can write over here, of 1,000 materials on 400 materials in 400 chunk I'm going to get. So in this internal table I will put 400 materials type, and then in associated type I can put uh, we can create quickly one table type so that I can assign over here. So what is I require to create a table type, what are the fields I require, because here in, just go back, for this IT underscore Mara we are having these fields, right? So just I'm going to create one table type. So Z TT Mara, ZTT underscore par Mara, just I'm going to create this table type, and Z S Mara, maybe I can put it over here, table type for uh, material update. Maybe I can write like this, material update. And in the line type I'm just going to give this value over here. So JDS underscore Mara, it's telling it is not permitted. Okay, it's fine. JDS Mara, just I'm going to give JDS Mara. So it's already there. Matner ER. Let me check if it is the same, then I can use this. Okay. So come over here, Matner MTAT MBRSH. It's a different. I can't use this one. Maybe one I can use over here, and it's telling, I think this is not, does not exist. Okay, I'm just going to create this one. I'm going to create this structure. So a structure for material update component, come over here, and we have the program already. This is the program. I'm just going to copy, alt shift copy, come over here, and I will paste it. Matner type 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 and type matnr matnr. Then maybe I can copy all this, paste it over here, press enter, and you can see everything is fine over here, right? Just save it, local object, activate it. I It got activated. Just come over here. I will activate this one also. This also got activated. I'm ready with my table type, and I can use over here. Press enter. So in this internal table I will get 400 materials. Okay, and that 400 materials, that's fine. Now I think it's fine. So only I have to get the material, right? Let me check. If something else required, we will declare and we will use later. Okay, so what I will do, that maybe I can use the same code. Just go back, go into display mode, and here create material. I'm just going to copy this code over here, right? I'm just going to copy all this code, and I will use it. I will use over here. Fine. So this function module. So here also we have to put the loop, right? Loop at the import internal table im underscore mara 400, right? Loop at into wa. This maybe I can use this work area over here, the same work area. Fine. Full stop. This w underscore head data, I need to declare this one. So I can declare over here data with the same. So just I can declare data, and the type which I have already created here, maybe I can use this type over here. Full stop. And it looks good now. Material description, this material description, no, 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 no. W8 data, this is the here. Actually I'm doing a mistake over here. Come over here in BAPI material, save data, head data, client data, and client data X. So these three are there. We can go inside this, and from here I can copy, but I have already over here. I will just copy from here. So I'm just trying to get. Okay, so I can come over here, double click, and data wa underscore head data. It's coming somewhere else. Just let me go to the program. Actually, yeah, this is the program. Here we have declared everything. Okay, so maybe I can copy all the required, right, so that I can use over there. So I'm just going to copy this much. Okay, come over here, and here I'm just going to check the syntax now. Some error is here. W underscore mara, all these things is coming, right? Fine. So loop at the im underscore mara 400. This w underscore mara maybe I can use over here, and this w underscore mara I have to define. So data w underscore mara type, and this structure, certainly it should be the one which I have created over here. So just I'm copying this one, and I will put it over here. Control B, full stop, check the syntax, and now in correct nesting it is telling fine. End loop I have to give, right? Here end loop, check the syntax, and the error handling, the message which I'm putting over here, this message just I'm going to this w underscore return, this particular message which it is coming over here. So this message I'm going to handle. So BAPI transaction commit, it's fine. Weight size was equal to 0, right? Not right over here. Just I'm going to use concatenate this, and is created into the message. Maybe I can use the message. Let me quickly declare one message internal table data ls underscore message msg type bapi read to, right? Let me check. Bapi read to, double click. Yes, it's fine. This is the structure. Okay, and then I will create one internal table, lt underscore message type bapi read to underscore t. Okay, so check the syntax. It looks good. ls underscore msg, fine. Now let me check. It's okay. ls underscore message must be a character like data object. Okay, so just what actually is there, I'm just looking into this. Let me check what is that. This is the message. Maybe I can use here to insert, and then this error should be gone. Okay, check this, and this time it is fine. Pretty printer, check the syntax, activate it, activate it, fine. It just got activated. So and this, just let me append this one, append this message ls underscore msg to lt underscore msg. Okay, but better this lt instead of lt, I'm just marking it as a et underscore msg because I will use it as a export parameter in this my function module. So go to et underscore and et underscore msg. I will give the type and bapi read to underscore t. Just press enter, come to the source code, and this et underscore msg is not required to be declared. Okay, so just I am putting into the export parameter, fine. Check it, activate it. Okay, so you must have some basic concept about this function module and all, then only will be able to understand the concept. Okay, so I created a wrapper function module in which I'm just using this, bapi material save data to update the material. Everything I kept same. So for 400 material I will pass in one task into this function module. Okay, now you can go into the attribute and you can select this remote enable function module. Okay, just activate this one, go into the source code, fine. And here now the loop at im underscore mara 400, all this thing is fine. Just go back, and what you have to do now, go into the main program. Where is come over here, this is our main program. Okay, so in the main program now what I'm going to do that, while putting the loop, okay, when we are going to put the loop 400, I will prepare the 4 internal table. Okay, or maybe dynamically also you can decide over here. So what you can do that, when I'm putting the loop over here, loop it underscore mara into w underscore mara, so maybe I'm just going to keep it simple as of now. I'm just going to keep it simple. So append uh, or maybe let me create the internal table of 400 records over here. So append wa underscore mara into this, append wa underscore mara to one internal table. Let's create over here lt mara temp, which is going to have 400 records. So one by one I'm just going to create over here, and uh, as soon as it's going to have the 400 records, as soon as it's going to have the 400 records, what will happen that it is going to call this perform create material. Okay, it's going to call this subroutine create material, and in this what I will do that I will put that parallel processing logic. Okay, so come over here, And what I will do, and that here, if site tabix, just I'm going to use the site tabix because loop I'm using over here, and use the mod 400, okay, equals to 0 in as soon as it will come to 400, equals to 0, what it will do, that it will call this perform, okay, and after calling this perform, in the second step it will just clear, it will just clear this lt underscore mara underscore temp, okay, and end if. And now, for now, that means the meaning of this means in this lt underscore mara underscore temp we are having, the 400 records, right? 400 records, because I'm just checking, I'm just dividing with 400, and if I'm checking if it's equal to 0. For the safer side, just I'm going to use the bracket over here, go here, click here, and the lt underscore temp, right? Lt underscore mara underscore temp, this I need to declare, I will declare that one, okay. Come over here, and here in this create material, what I will do, that I will call that function module which I have used over here, right? So just I'm going to comment this, or maybe I will delete this, this is not required, okay. So the function module which I have created over here, this is the function module. This function module you have to call, okay. So how to call this function module, there is some certain syntax that we have to use, okay. So maybe that syntax I will let you know over here. What you have to do, that you have to call the initially it will be same call function, and you have to use the uh, you have to use the function module name. So what is the function module name, just go here, let me close the extra session. Fine, this is the function module name, I'm just going to copy this one, call this function module, and after that what you have to write, that starting new task, because every time you are going to, you know uh, create the new task, right? So you are calling this function module in a new task, and you will give the name of the this new task name, you will define any name, means every time when you are going to call in a new task, you can uh, so you can put the task name in this variable. So we'll define this variable, just I'm putting into these brackets now, as of now. And after that what you have to do, that you have to write destination in group, okay. So just you want to tell to the system that in which server group you want to, you know I discussed in our first video that we are not supposed to use all the resources of the server, right? That's why we are just going to use the server group, so that the dedicated server only we are going to, not all the server, just dedicated server, allocated server we should be able to use. So just I'm going to use destination in the group, right? And after that you can write the performing, the subroutine name, any subroutine you can define, okay. So subroutine we are going to define later. So performing subroutine, why we are going to define this subroutine, to handle the result, okay. To handle the result we are going to define the subroutine on end of task, on end of task. So the task, this is the syntax you have to use, and after that you are having the exceptions. So the exceptions, it can come something like, communication failure, this is one exception, and this is one, that the message, it can be given, the value can be assigned to this, maybe lv underscore message, we can write it over here. Then another exception what it can come, the system failure, okay. The exception handling is very very important in this parallel processing, okay. So lv underscore message, and again the third one, resource failure, resource resource underscore failure. resource underscore failure equals to 3. That's it. And if you have some your own exception defined in this function module, the function module which we have created over here, right? The of course we have to put in the single quote over here. I just missed put in the single quotes, double quote, double click over here, and it is here, right? And if you have some your own exception, something, maybe I can put some exception over here, test exception, come over here, and this time I'm going to just put some exception, my custom exception. If you have some your exception, so just I can put this exception over here and my exception. Okay, just click on the save button. I will activate once again. So this exception also, you can use it here. Mm, just go back, just go back. You can use your exception also over here. Control V, and you can assign this one like that. You can do. Okay, so your exception also you can define over here. And once you define all these things, you have to handle the exception, right? So we are going to use the case statement size sub rc, right? This is how we handle the exception size sub rc. And when when one or two, right, then just I'm going to combine, because this one and two we can combine it together. So just I'm just going to make it very simple as of now, and then the different variant I will let you know. Okay, so when one or two or three or four, if it is going something like that, what I'm going to do, what I'm going to do, that see, so every time when we are passing the data, like when I'm passing the data, see the exception, this is the exception, and this is the function module. So this is the exception and function module, and in this function module you can see that we are having the parameters, right? So we, we must have to supply the export parameter from there, right? So im underscore mar underscore 400 in this, here, performing all these things. Here what you can do in exporting, you can give this value over here, and the uh, the the value which we are preparing for the 400, right, lt mara underscore temp, that we can pass it over here, that we can pass it over here. So control V, and it's fine now. Just save it with the printer, it's okay. So what I'm trying to do, see, every time when you are going to put into the loop, right, when you are going to put into the loop, what you are going to do, that this task name, the new task, right, this task name you have to create over. So maybe I'm just going to make it as a global variable. Okay, it will be easy for me. So just I will put this uh, gv task. I will define this gv task. So all this definition and all these things I will tell you in the next video, how we can put the, because this video is going to be a longer. So maybe in the next video what I will do, that for this task, I will let you know how we can define this task, and what in the server group we are going to pass, and again also we are going to define the subroutine. Okay, and in that subroutine how we are going to handle the results. So in the next video we are going to check that one. And here, first we will keep it very simple, and then we will see like how we are going to handle the different exceptions in the different way. So from easy to advanced we will go. So just I'm going you to give little idea over here. So in case of one or two or three or four, I will keep one flag. Okay, so in case of any error, and all these function module things, the calling this function module, I will put in a endless loop. Okay, endless loop in case of any error, in case of any error. So in case of any error, if it comes, what I will put over here, that when one or two or three or four, I will set a flag. Okay, I will set a flag lv underscore error. Okay, and equals to, just passing it over here, x, and if it's 0, and when it's 0, then in that case what I'm going to do, I'm going to clear this LV error. Okay, I'm going to clear this LV error, that's it, and end case I'm just going to keep. And here when, so this is for the, like for the first 400 records when it is coming, so I'm treating for the first 400 records, for the first 400 records I'm treating over here. Okay, so in case of 0, uh, when it's 0 case, end case, it is fine here. And after that I will check, after that I will check if the lv underscore error, you know lv underscore error is initial. Okay, if it is initial, that means this function module got successfully called. Okay, that means this function module got successfully called without any problem. Okay, without any problem it got called and there is no issue. Okay, so now what I will do, that in case of lv underscore error is initial, I will just come out from this loop, because now it is not more required to be into this loop, because my dialog process has been called successfully for the 400 record to be to get processed. Okay, so this is, so tomorrow we will define this db task server group subroutine, and we will handle the result which we are going to get the message from this particular function module, and we will display in the same way as we have seen in the yeah, for the normal program how it's going to display, right? So we have seen somewhere it was going to take something like you know uh, it was taking somewhere around 258 seconds, if you remember, right? I missed to uh, note down that one, but it was somewhere around 258 seconds. So in beginning of the video it is there, you can go there and you can check for the 2000 records how much time it is taking. And by with the help of, and with the help of this particular technique, we are going to reduce the time. Okay, so we'll check how much we can reduce the time. So maybe at this point of time, let me check if I can activate. No, because many things we have to still define and declare over here, so that's why it is not allowing. So I'm just going to save it and just save this one as of now, and tomorrow, or maybe in the next video, in the third video, we will see the remaining part. Okay, thank you very much for watching. Thanks a lot. Bye bye.